sorry, IA into ZS, and this ZS is nothing but RA plus J XS. So this EPH will be VT plus IARA plus J IA XS. So we have considered three particular load condition. One is a lagging power factor load. So in case of lagging power factor load, if I'm going to take IA as a reference, VT will lead to the IA by angle phi. That means if I'm going to take Vt as a reference, Ia is lagging to Vt by phi. See, in case of lagging or leading, current is lagging or leading. Means, as we are saying, lagging power factor load, that current is lagging to the voltage by angle phi. So Ia is taken as a reference. This is Vt. You know that EPH is nothing but the phasor addition of Vt plus IRA plus IXS. So if I'm going to plot the phasor diagram, it will looks like this. I did some rearrangement, and after considering triangle OAB, in triangle OAB, we may say that as per the Pythagoras theorem, OB square is equal to OA square plus AB square. And what is OA? OA is nothing but the addition of OE plus EA. Similarly, AB is nothing but the AD plus DB. Accordingly, if I'm going to place the values of OE, EA, AD and BD, I will get the equation EPH square is equal to VT cos phi plus IRA square VT sin phi plus IXS square. So EPH will be VT cos phi means under root this term. This is for lagging power factor load. Same for leading power factor load. Current is leading to the voltage by angle phi. This is Vt. Current is leading. So after just going through this phasor diagram, finally we'll get the open circuit voltage EPH is equal to under root Vt cos phi plus IARA whole square plus Vt sin phi minus IAXS bracket square. In the same way, if we are going to see for a unity power factor load in which that current and voltage are in phase, we will get the equation for EOC or EPH under root Vt plus IRA square plus IXS whole square. So once we got the EPH, and if we have measured the Vt, we can find out the voltage regulation as percentage voltage regulation. It is nothing but the EPH minus Vt upon Vt into 100. So based on that, I told you how to calculate or how to do the calculation for solving the numerical on voltage regulation, and we have stated one numerical. So let us solve this numerical. What is that? So let us solve this numerical in which a three-phase 1500 kVA 2300 volt star connected alternator has armature resistance of 0.12 ohm per phase. If field current of 70 amps produces a short circuit current equal to 300 ampere and same excitation produces EMF of 700 volt on open circuit between the lines, find synchronous reactance of machine and regulation at full load 0.8 power factor lagging. So you know that the apparent power, it is given as a how much? 1500 kVA. So we can write down it is 1500 into 10 raised to minus 3 volt ampere. RA is equal to what? Here RA is equal to 0.12 ohm per phase. Then what is ISC? Can anyone please tell me? The short circuit current equal to 300 amp. So it is 300 ampere. What is open circuit voltage? VOC 700 volt. But this is line value. So how to calculate EOC phase? 700 divided by root 3, 404.145. Again, one more parameter. VT is equal to how much? Just tell me the terminal voltage. This is VT line 2300 volt. And VT phase by using same formula 2300 divided by root 3. So it will be how much? 1327.9 volt. So once we know the parameters, see, this is the numerical on synchronous impedance. So how to calculate synchronous impedance? Right now, this is a 0.8 power factor lagging load. How to find out no load voltage? EPH, that is no load voltage, is equal to under root Vt cos phi plus IARA square plus Vt sine phi plus Ia x square. What is unknown? We have to calculate EPH. Vt is known, right? Cos phi. Here in this case, power factor is 0.8 lagging. That means cos phi is equal to 0.8. So from that, we can calculate cos phi as well as sin phi. Again, Ra is also known. We have to calculate what is Ia and what is XS. To calculate Ia, we know the rating, that is S. S is equal to what? Root 3 into VL into IL. So what is S? S is nothing but the apparent power in VA. So its value is 1500 into 10 raised to 3. This is root 3. Okay, what is line voltage value? 2300 into IL. So what is IL from this equation? Just calculate and tell me. 1500 into 10 raised to 3 divided by root 3 into 2300 to find synchronous impedance. So synchronous impedance formula is, yes, ISC. See, this is star connected. Okay. In case of star, IL is equal to IA, line current is equal to phase current, right? But or IL is equal to IPH, but voltage is not same. That's why we have to consider EOC per phase divided by ISC. EOC is equal to how much? 404.14. This value. Okay. And what is ISC? ISC is equal to how much? 300 ampere. Okay. So let us calculate
1.3.
1.347 1.347 ohm per phase. So right now I have just got the values of ZS, and what is the formula for ZS in terms of RA and XS? ZS is equal to under root
Under R
RS
square
squared
plus
plus
X square.
XS square. So from this formula, what is XS? It is under root ZS square minus RS square. So let us calculate what is ZS. 1.347 square minus RA is equal to 0.12 square. Calculate it. 1.347 square minus 0.12 square. Square root of the answer, it is 1.341 ohm per phase. Okay, so I know all the values which are required for calculation of, that is EPH, which is nothing but the no load voltage. What is cos phi? Cos phi is equal to 0.8. So from this, phi is equal to cos inverse of 0.8, which is equal to 36.86. 36.86. So what is sin phi? It is equal to sine of 36.86, which is equal to, that is sine
0.6.
of the answer. Yes, how much? 0.6.
0.6.
Okay, very nice. So I know all the values which are required to calculate EPH. So EPH is equal to, see, right now it is a lagging power factor load. So for lagging power factor load, what is the formula? Yes, Vt cos phi plus
Plus
IARA
IRA
whole square plus Vt
VT
sin
sin
phi
plus
plus or minus.
IAJ
Here it is
plus
plus or
plus
minus.
plus
Plus, very nice.
I
IA into XS
X
whole square. So let me put the values of each and every term. So Vt is equal to how much? We have to take this value Vt. It is equal to 1327.9 into cos phi is equal to 0.8 plus Ia is equal to how much? This is the Ia, 376.53. So 376.53 into 0.12 whole square plus 1327.9 into 0.6 plus 376.53 into xs is equal to 1.341 whole square. Do the calculation, tell me the answer. 1708. This is EPH. Yes, sir. Chinmay. For 0.8 power factor lagging, voltage regulation, percentage voltage regulation, it is equal to EPH minus VT divided by VT into 100. Okay, so I will place the values. What is EPH? 1708.7 minus VT 1327.9 divided by 1327.9 into 100. So percentage voltage regulation is equal to 28.66%. So this is nothing but the voltage regulation. We will solve the another numerical. Second numerical. 100 kVA, 3000 volt, 50 hertz, three-phase star-connected alternator has effective armature resistance of 0.2 ohm. That is RA is equal to 0.2 ohm, right? Then a field current produces 50 ampere. Okay, field current of 50 ampere produces short circuit current of 250 ampere. That means for IF is equal to 50 ampere, ISC is equal to how much? 250 ampere. Then open circuit voltage, that is a VOC, is equal to 750 ampere, sorry, 750 volt per phase. Again, you have to calculate the percentage voltage regulation. Just try to solve it. ISC is known, VOC is known. I have to calculate IA. What is IA? IA is equal to, can anyone please tell me? S is equal to what? Root 3 VL IL. Okay. So as it is star connected, this IL is equal to IA, which is equal to S upon root 3 into VL. So this IA is equal to S divided by root 3 into VL. What is S? It is 100 kVA. That means 100 into 10 raised to 3 divided by root 3 into VL. VL is equal to 3000. It is coming as a 19.245. Now next step is synchronous impedance. So synchronous impedance, ZS is equal to how much? VOC upon ISC, but both the values should be phase value. VOC phase upon ISC. VOC phase is equal to 750 volt and ISC is equal to 250. So it is coming as a 3 ohm per phase. So I know the value of ZS. So XS will be under root ZS square minus RS square. So what is ZS? 3 square minus RA is equal to 0.2 square. So it is coming as a 2.99. 2.9933 ohm per phase. This is also ohm per phase. Okay, so XS is known. Again, we have to calculate the voltage regulation for cos phi is equal to 0.8. So from this, phi will be cos inverse of this. Phi is equal to cos inverse of 0.8. So it is coming as a 36.86. So what is sine phi? Sine phi will be sine of 36.86, which is equal to 0.6. So if I know these values, let us calculate voltage regulation. To calculate voltage regulation, we should know VT, and VT is nothing but this VL upon root 3. VL is equal to 3000 volt divided by root 3. 1732.05 volt per phase. So Vt is known, sine phi, cos phi is known, xs is known, I is also known. Okay. So let us calculate for lagging power factor load. This EPH, which is nothing but the no load voltage, is equal to Vt cos phi plus IaRa whole square plus Vt sin phi plus IaXs whole square. I will place the values. Vt is equal to how much? 1732.05 into cos phi is equal to 0.8 into, sorry, plus Ia is equal to how much? 19.245 into Ra is equal to 0.2. This square plus Vt is equal to 1732.05 into sin phi is equal to 0.6 plus 19.245 into x is equal to how much? 2.99 whole square. So after doing this calculation, the value of EPH, it will be 1770.22 volts, and percentage voltage regulation, it is equal to EPH minus Vt upon Vt. So this is equal to how much? EPH is equal to 1770.22. Vt is equal to 1732.05 divided by 1732.05. So this will come as a 2.2% into 100, no? Into 100. Here also it into 100, it is 2.2%. And for leading power factor, EPH is equal to PH. Is it coming as a 1701.74 volt? So finally, the percentage voltage regulation will be EPH minus Vt. EPH is equal to 1701.74 minus Vt is equal to 1732.05 divided by 1732.05 into 100. So this will be minus 1.775%. Okay. I hope you understood this.